right, yo, say, there we go. Let me put this thing properly in place so you can see me. All right, so as I was mentioning, I will talk about what we lectured the last time, like 2 weeks ago. And then after that, I'm going to talk about the IO formatting and input, output, receiving, and all the good stuff. And then after that, if we have time, I'll give you an introduction on um, inheritance, and we'll call it a day. So the next day you are coming in, you are going to have uh, definitely have all the marks for your midterm and your workshops that you submitted down to this point. Please go through them, and if you have any questions or anything, remember that you have 1 week to debate the marks. I will set an announcement, and I'm going to say you for 1 week. You have 1 week to book an appointment. Now, the appointment can be done after a week, but you must initiate the fact that you want to debate your marks, and uh, after a week, then you cannot change anything with it about it. That's all. Now, let me set the poll ready and start with any questions, anyone? Fantastic. Quick response. Very nice. Very good. So everybody said no. Let's begin. I'm going to do an anonymous poll, and I want you to honestly answer it. I'm not going to know who answered. So it's got to be an anonymous poll. And then I want to check the percentage with what's coming up in your marks. So get ready for this poll. Please answer to the question in reality. Don't be modest and don't be over enthusiastic. M- Answer exactly uh, what do you think about this? And anonymous on, so I don't see who's doing what. And let's go. About your midterm. 3 more people. I don't know who is not responding, but 3 more people. And one last person who's not replying. One last person, one last person, two, one last person, three. Publish. All right, I'm gonna do a copy of this. Sorry, just a second. There we go. Okay, and I'm gonna save this. Thank you. Let me make sure that it's in place. Yes. Okay. Thank you. And then we're gonna see with the results, and hopefully after that it's gonna be something nice. And then again, I'm assuming 18 people are here now out of 30, so it's not a precise poll, but anyways. Okay, so let's do this. We talked about operators. We said we have two different types of operators. We have unary and we have binary operators. And we said all the operators return values. So whatever the operator is, a value is returned, and the value is captured as a result of this value that's created. Whatever is there will receive that value. Binary operations are two different ones. There's side effect, the one that has side effect, and the one that don't have side effect. The ones that have side effect, they uh, they don't have side effect after the operation is done. The left operand and the right operand remain the same, as are these. And the ones and the usually the uh, general signature to overload such operator is that the left operand is the owner of the operator and the right operand is either passed by value or it's a constant value. So, and all these things are always constant because they are not changing the left side. No side effect means the uh, method belonging to the left operand is constant, and the right operand is either passed by value or passed by constant reference. And we talked about operators with side effect. Now this is left side effect, which means the method that is called from the left operand is not constant, which means it can change the left operand, but obviously the right ones are either uh, by value or by constant. So if you wanted to have something like this, right side effect, then this will be constant, and this one will be just a reference, which is going to be something like, say that. So you're extracting something out of B and put it in C, so C will change afterwards. It's just an example. And it returns something as a result. Okay, so unary operators, we said that because they're unary, they're one operator, although they are coming before the operand, they are a member of the operand, and they could have either side effect or no side effect. Um, and we mentioned that you cannot uh, overload this. I don't know why I wrote this thing. So you can't create a new unary. It must be unary itself to be overloaded. So you can't write something like this because plus equal is a binary operator. You cannot change it to anything else. Always remember that what you're doing is uh, an overload, not creating a new operator. Prefix unary operators with side effect are plus plus and minus minus. These are the two, and when you don't write anything over here, they are prefix. To make any plus plus or minus minus postfix, you add an int in a second one. That int essentially does means nothing other than the plus plus is coming after. It's not an argument, it's a flag. And we said we have index operator where you can actually pass the two arguments to this. One is the owner, that is the left one. The right one is the subscription value, whatever it is, the index that you want to pass to it. And don't forget that this is uh, an overload, which means I could have something like this, for example, saying, um, say I have a class called phone book, and this class of phone book of mine has long get phone, long operator, and in here it's going to have a constant character string that is the name. So what happens is that this phone book of mine essentially has an index operator that works like this. So you can for example, what you can do in here, you can say, for example, see out. Let's say I have a phone book Seneca. So Seneca is the phone book. Now I can say see out far that's phone is, and you say Seneca, and inside the index operator you put Fardat Soleimanli. It's perfectly valid thing, which means Fardat Soleimanli will be passed to name. It's going to search for the name, find the phone number, and return it out. And the output of this will be something like, say this. Do we understand what just happened? Let me bring the poll up again. Where are my polls? There we go. Do we understand this? All right, perfect.
Sorry, could you repeat that last part
This part.
about the output? Yeah,
So
yeah.
stay with me. So we know that index operator is supposed to get an index. Usually this is a number, like you have an array and you say index number 5, right? Are you with me?
Yeah.
Yeah, yeah. So now if you're
Yeah.
looking in a phone book, the index you are looking in for is not a number anymore. You're looking for someone name to find the number, right?
Okay. Yeah.
Therefore, the index, that what we call a subscription value, whatever the subscription is, it could be an integer for an array, it could be a name for a uh, for a phone number, it could be a license plate for a car. Depending on if you have, like for example, a class parking, your parking class could have an operator that returns a car and receives the license plate. You follow?
Okay.
So it essentially
Yeah.
becomes a dictionary. And the key of the dictionary will be essentially the key will go to the dictionary, and what is being returned over here is the value of the key. Got it?
Yeah.
All right.
All right. Sounds good. Thank you.
No problem. Two people said no. So did I answer both? Three people. Did I answer all three, or there's still something unclear?
Yes.
Okay. All right. All right. Okay. So that's that. Let's start with the next one. so let me go to the, oh, nice. So it actually tells who said what. You can actually get the whole thing in a public chat now. It's a new version. So if I put anonymous, I'm not going to see who. Oh no, it doesn't. Good, good. It doesn't put that in the chat. It just puts the bars. That's fine. All right. Okay, so that's that. Oh, and every time I do a poll, it goes back to, huh, okay. All right. So that's that. Also, we talked about type conversion. So if you want any class to be able to be convertible to a type, you can create a type conversion. Type conversions do not have return value for all those who actually put return value for them. They don't have return value because by nature, what they return is the type. Yeah. So, um, for example, if I have uh, classroom, and this classroom has integer or size t, or let's say integer size, I can have the uh, integer cast operator. So I can say operator int const, and in here I can say return size. So say we have a proper constructor over here. If somebody creates a classroom C with size of 40 people, so essentially we have classroom int s, and in here I'm saying size is s. If somebody does that, we can actually say cout the size of classroom is good for, now in here I can say integer c. So essentially cast the classroom to an integer, and this cast will call the operator and return the size. Are we okay with this? All right. And that, ladies and gentlemen, was the total review that we had for the operators. Let me save that in today's session because it's changed with the other one. And we did the exact same thing with the container. All those examples were done in a container. One person is saying no. What question do you have? What is your question?
I'm sorry, Professor. I disconnected,
Oh, you're all
and I
disconnected.
can't. Yes, it's,
Okay, so
I don't understand what you said at last.
okay, no problem. I just asked if everybody's okay or not. That's it.
Okay.
All right. So that's that. So we're good. So I'm gonna stop it. I'm gonna continue with the next one. So yeah, let's go answer. Okay, so we are good. Let me see. Yeah, so we did that for the container. We created the binary operator that is, as left side receives a container, at right side receives an integer. This is a binary operator. At right side receives a constant container, and left side returns a container. So essentially a container plus a container. Here is a container plus an integer. Here's a container minus equal to an integer. Container that returns the reference of the current one, plus plus adds one, plus plus after adds one, Equal sets the container to a value. Display displays, we explained that. Int operator over here is an operator that int operator container. What did we create this for? This is an unusual one. Let me see what we have done over here. So operator equal with, so essentially this operator equal at left side it receives a container because it's the owner, at right side receive another container and pours one container into another one and returns how many things it poured. This integer returns the content, and I said never use friend methods, friend containers, friends in any type of class. For making a friend of a method, it's always lack of proper design. We created helper operators. We said that all the operators that you do as methods can be overloaded as standalone operators, as standalone operator overloads. We call these helpers. You do this when you don't have access to the left one. In any way, if the left one is a primitive type, it cannot have a method, so it has to be like that. Or if the left one's code is not accessible to you to modify, then you use a standalone method. And that's overall the entire review of operator overloading. Any questions about operator overloading before we complete the integer array with the dynamic memory allocation to kind of review that one? Any questions? All right. Thank you. Oh, somebody had a question. Who had a question? Somebody said yes. And I clicked yes right at the moment. Go ahead.
Because I disconnected. I don't know what happens at the last.
You keep disconnecting, my friend. Go at a place with a better reception, please.
No, I'm in the college and everything is okay. I'm not sure it is my problem or
So,
from any
what
country.
I suggest, if you have any kind of headset, it's better to
Yes,
go.
I'm using my headset, but no, it's okay. The
Okay.
last thing you explained before the containers, if possible,
Oh,
say it again as short as possible.
okay. Sure,
If
sure.
not,
No problem.
go ahead.
I just mentioned the only thing I mentioned was that not to use friend for uh, standalone operators and standalone
I got it.
that
The
was the one.
thing you explained before that,
Before that.
before the previous polling.
So I don't remember what it was. Please,
Okay, go ahead.
please.
Thank you.
So
I'm
the
so sorry. I'm
timing
sorry.
for the thing is 20. So you have to go to 21 minutes. Remember, okay?
Okay.
Go
I
to
will
minute
come back and say
21
it.
in the recording. That's where that thing was talked about. I don't remember
Okay,
what it
thank
was.
you. Thank you.
Sorry
I'm
about
so
that.
sorry. I'm sorry.
No. Don't be. All right. So that's that. Now, let's talk about integer array. We create an integer array to demonstrate the index operator, and then an integer array, we said an integer array essentially is an integer pointer pointing to a piece of memory somewhere, and that could be dynamic, so it's not in our codes, and we made a safe integer. So when people created the array, first of all, array knows what its own size, and secondly, when it's passed around, it knows what its size is. And also the index operator over here will not bypass the size of the array, and therefore the array is safe. So, and by the way, this could be a good question for a quiz. So be aware of it, please. All right. So now, when we look at the we know the implementation of the index operator, and we are passing it in an index, and we created two different ones, one with non-constant, the other one's constant. The reason we did that is that when you create the array, for example, an array of 10 integers, and I'm going to say integer I0 and J0, and I'll go I from 0 to 10. That's going to be the index, and j are going to be the values that I'm going to put in it one by one. So what happens is that j will be 10 first, and it keeps going. So in here, the I index that is being used is non-constant because it returns the reference of the element we want to put the thing in. It changes the array. It cannot be constant. But when a display is called, we said whenever you are using a function, creating a function, and the logic of the function is not supposed to modify the function, make sure your function receives constant, sorry, receives constant or receives um, constant references or constant pointers. To do that, then I have to pass a constant reference of the integer array. If I did that, then the index operator cannot be accessed. Because of that fact, what I did was creating a constant version of the index operator. In this case, the constant and non-constant have the exact same logic, but the only difference is that this guarantees that nothing is changed in here because it returns a constant reference out, and because it's the constant reference, nothing can be changed inside the array. And that's how we did it. So if I run the program, we will see that it simply um, starts the application by creating the integer array. So it goes in here and sets all the values to 0. Then it allocates 10 integers and puts the address in mdata. And also it sets the size to 0. And now you see that the mdata over here is all garbage. We could have actually set everything to 0 over here, but I didn't do that. Okay, so and then the m size over here will be set to 10 because size is 10 that is passed, so it knows that a size is 10, and it's created. Now when I come to the loop, it has I as 0, j is 0 plus 10, it's going to be 10. Therefore this is going to be called. When it's called, I will be passed as the argument to the index. So index will be I, that is 0. Then it says it checks what it wants to return to garbage first initially, then makes sure if the data is available. Now there is no garbage, so I have 0 mod 10, which is 0. So the reference of mdata 0, which is the first element, will be sent out. Therefore what is being returned is the reference of the element 0, and that is the one that it will be set to 10. And as soon as we bypass this, if we actually go over there, we'll see the first value over here is actually 10. Now we continue this and keep going. So the second one will be 20, 30, 40, 50, 60, 70, 80, 90, and 100. And then it comes out of the loop. Now it goes to display. Again, unlike regular array, I just pass the name of the array and I receive a reference of the array, and because this is now an array that is actually a class, it knows what the size is. So one by one goes through it and prints it. If it's the first one, no comma, then it comes in here, I0 will be passed. Because I is a constant integer array, when it wants to come over here, it cannot call this method because this method is not constant. Therefore the object may change and the object is constant. Because of that fact, the one that matches the constantness of the object will be called, which is this one. It does the same thing. The only difference is that everything is constant over here. So it returns the value and prints them out one by one as we see it here. Up to 100 and comes out. And that's it. So the good thing about this is that if I actually go over here and I say I want an array of 10, and by mistake over here I put 12, nothing bad is going to happen because of that modulus thingy that we had, it's going to loop back and it's just going to destroy the first two elements instead. You see these two? So it starts from 10, 20, and it keeps going up. As soon as it passes the index, it's not going to ruin anybody's memory, it's just going to ruin its own. And that might sound good, but I don't want that to happen. I want it to be better than that. I want this thing to resize itself when the time comes. When the time comes. So now I'm gonna modify the code of uh, the integer array so it essentially resizes itself when the size passes the threshold. Are we okay with this? They changed the thing. Now I have to retype the question every single time. Okay, so let's do that. So we're gonna come over here. So the constant one will remain the same. If it's constant, it's not supposed to change its size. So if I'm passing a constant array to someplace, I'm saying it's constant. Constant means charge size won't change. But in this one, I can actually change the size. So what I can do, first of all, garbage returning is not needed anymore. In this one, I need the garbage because when it's constant, I need to pass the garbage out. But the other one, because I'm resizing, I don't need to send garbage out. I'm just going to resize and send the proper index to it. So what do I need to do? I need to check to see if it's out of bound. Okay? So for the value for the index to be not valid, what should I check here? What should be the condition of my uh, what should be the condition of my huh they changed the place that I could select a student. What happened? I could actually randomly select someone. New update is up and I don't know where to do that. Share camera as content, external video, start a poll. Hmm, here maybe? Hmm, what happened to my random selection? I'm so sad. Is it this one? No, I'm raising hand myself. um, damn it. That was such a nice feature. I don't know what happened to it. Active stop timer, share an external, upload, welcome, default. Anyways, somebody answer. Man, John Howe, please answer. What do you think? What should be the condition in here for me to resize the thing, the array, based on index and size?
I can answer, Professor.
Yeah, go ahead.
Okay, we have to check the index which pass inside this uh, operator with the index maximum index size.
Maximum index size, that is m size. So if index is m size, that means we exceed it because the index can never be at the size of the thing. So what I'm going to do in here is this. It's very simple and straightforward. I'm going to say if index is if index is greater is equal to size, it means uh, I don't have a I don't have enough space. All I need to do is to resize this class into index plus 1, right? So if I do something like, and I do not need ret over here, Yeah, and with this, the data can never be null because if the data is null, it's going to create one. So let's do it like this. I can simply say return. So my code changes to this one. And I do not need this one either. So it's going to be return like this, index. So I'm saying if index is equal to m size, resize to index plus equal, no, greater than or equal m size, resize to index plus 1, and then return whatever the index is. And I have no idea why is this one doing this. We'll see. I don't know what's going on in here, but when the resize is written, probably that's going to be fixed. So I'm going to write the code that resizes. The way I see over here, we are having a size which is saying if it's null, it returns garbage out. Okay, so let's create resize. So I'm gonna create a function in here. I'm gonna call it size t resize, and in here I'm gonna have a size t new size. Whatever size they give me, I'm gonna resize it to that one. So that's a size t and resize. And in here I have to make sure everything works perfectly. All right. So when a new size is passed in, the very first thing I need to see if that um, the very first thing I need to have over here is a memory to the size that I have, the new size. So in here I'm going to say integer pointer new mem, and I'm going to say equals to integer new size. So that's the very first thing that I'm going to do. I'm going to set my size to new int, sorry, to new int. So now I created a new size for whatever I have. And then what I have to do over here, I have to start from the beginning of data and keep copying everything from the old one to the new one. Anybody wants me to bring up that new size slide before this and take you through the slide and before I do the resizing, or this is good? So anybody wants me to show you this slide for resizing first? Wow, everybody's saying yes. And no, actually, wow, there's a fight going on in here. Eeh, okay, vote. Just to show you how close it is, I'm going to post it now. So you see that? So we have lots of yeses. So I'll bring the resize up very quickly. It should be somewhere. Let me add. It should be somewhere around here. I had it somewhere. Anyway, remembers where it was, by the way? The resize thingy for dynamic memory allocation. Huh. Oh, memory resizing. There you go. So let's bring it here, paste, and add. The document is either unsupported, yada yada. Don't, okay. Oh, there we go. It's opening it. There we go. So I hope that the settings are fine. I'm just going to start the, yeah. So when we are dealing with size in here, we want to change the size. In this scenario, m data is already pointing to something, but remember in our array that the m data may be null. In this case, we are in a good situation with m data has something. We're going to design it like this, and then we're going to take care of the other one. So this is the original size of my data. Then I want to increase the size. So temp is the new size. I did that already. That's the first thing I have done here. You see int new mem is yada yada yada. So new mem is essentially the temp in here. And then after this, I need to copy everything from the old one into the new one by one. Okay? So we can do that. We can come over here and say for size t set to size ti set to 0 and I less than the size. Now, in this scenario, the size is bigger than m size. I'm writing the function in a way that even if you shrink it, if you later on have an array and you want to shrink the size of the array, you would be able to do that. So if you want to do that, if we want to do that resize, I will actually implement it that way. So it could have been that the size is bigger than m size. If that's the case, I have to make sure that new size and size they're both met. So I have to say if I is less than m size or I is less than new size. Oh, sorry. If I is m than, how do I write it? I is if I is less than m size or I and I is less than new size. So it has to be less than both of them and I plus plus. Now I'm going to copy everything from the old one to the new one. So I'm going to say new mem I will be set to m data I. So at this point, everything from the old memory is copied into the new memory. Old or new, it doesn't make any difference. And even the case that we had for m data to be null is covered too, because if m data is null, by default the size will be 0 too. If the size is 0 and m data is null, then actually our constructor is a little iffy over here. So I have to fix the constructor. Um, I can actually put a default value. Let me see what is the constructor over here, default value. So I can actually set the default value to 0 for size, and I can come over here and say if size is not 0, do this. And that's it. So now it's actually fixed. Therefore, the data is null originally, but if the size is not 0, it means something needs to be allocated, it will allocate it. Otherwise, the allocation is not going to happen and m data remains null. So we're good. And also, if m data is null, then size is 0, and because size is 0 over here, m size less than 0 will go false, and then this will never happen. So resizing will work perfectly. So that's that. So down to this point, I copied everything from the old one to the new one. Let's go back over here. So after everything is copied from the old one to the old one is not needed and we can completely delete it. So that's exactly what I'm going to do. I'm going to say now the new one, that everything is copied, delete m data. And now that the m data is deleted, I need to put a new address in m data that points to new size. So essentially what I need to do is to make m data, obviously I have to update the size, so let's do that before I forget. So I'm going to update the size. So essentially m size will be new size. That is done. M size is new size. And then after this, what I need to do is to can you hear me? Can you hear me?
Yes.
Yeah, because my
Yeah.
screen went blank. I don't know if I said network. You can see
Yeah.
I don't have anything. This is my big blue. Oh, you can see. Can you see my
Yeah,
screen?
yeah, we can see you. We can see the presentation good, yeah.
Huh.
Yeah, we can see your screen.
That's interesting. This is my big blue button. You see that? There's nothing
Yeah.
in here. All right, so we'll see what happens. I'm gonna finish this, then I'm gonna check it out. Anyways, good. So if you can see me, that's fine. So yeah, so that's that. And uh, now that it's done, I'm gonna make mdata actually point to the new data. And after everything is done, mdata will point to the thing with the new size. And that's the gist of everything. So let's stop this, and I'm gonna write that right over here, and I'm gonna write over here mdata will be actually new mem, and what is going to be returned is the new size, just to see what was the new size. Do we need to return new size? Nah, because new size is there. Why do I need to use it? So I'm gonna return this instead. Whenever you don't know what to return, you see the return value is not important, don't return void. Put over here, I'm going to put over here int array reference, and I'm going to return this. So I can do cascading if I need to later on. So it's going to be star this, and I'm going to go over here and change that resize thingy to int array reference. All right, so now that the resize is written over here, what I can do is uh, refresh my screen. And as soon as I refresh my screen, I'm going to get disconnected. So bear with me. I'll be back. One,
One.
two.
Two.
All right. Can you hear me?
Yeah.
Okay, perfect. So
Two.
let me just share the screen again because I lost it. I just want to make sure that share the screen again, entire screen, share, and the recording is continuing. So life is beautiful, beautiful. So let's do that. So now that we have done this, now that this resize is done, then everything's going to be automated, which means if somebody exceeds the size, as the size is being exceeded, automatically it's going to adjust its size to what it's needed to be. And that's beautiful. So now I have size of 10. It keeps going like this. Oh, build errors. No, let me see what was build errors. Return cannot convert from integer reference to integer pointer to integer reference. This is not an integer pointer. What the devil? What the heck it's talking about? This is integer reference. mdata is a pointer. Oh, yes, absolutely right. Shoot, my apologies. This makes it a reference. Why do I have an ampersand over there? Bad boy I am. In here I needed the address because I had to change it between garbage and reference of the thing. Over there I don't need to. So absolutely right. Anyways, let's continue. So we'll continue. It comes over here for the first 10 life is beautiful, and as you see it comes in here and says, do I resize? No, I don't. It just sends the data out, and it keeps going like that again. It comes over here, do I need size? No, it keeps going. So I'm going to put a stop sign over here and run it until it gets there. So as soon as the I over here becomes 10, now it's equal to M size, therefore the size is not adequate anymore. So it makes it 10 plus 1, 11, resizes the array to 11. So now we go up, the new size is 11, memory is that, and the first 10 will be copied, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now that everything's copied into mem, we delete the data, we don't need it anymore. We make the size 11 and make the data point to the new data, and we return. Now when it comes out, it's returning the index 10, which is the newly allocated thing, So everything is fine and dandy. And it does the exact same thing for the next one. So when the next one goes over here, the index is 11, and now it becomes resizes it to 12 and comes out. And when we now go to display, you will see that the size in display is no longer 11, but it's 12. So it prints everything over there. 40, 50, 60, 70, 80, 90, 100, 101, and 120. And therefore the array now grew with the size. So this array int array of mine is now perfectly to use for any integer array that we want to use, and we are not sure how many things we have. So for example, you want to get uh, values from user and you don't know how many numbers user has, you can create an array with size 1 and start asking with user enter values, and say you want to continue, and the user keeps saying continue. Whenever user stops, your array is exactly the size of the values that user is receiving. Therefore it resizes it as it goes through. Are we okay with this? Well, I have to send them a feedback on this. Are we good with this? All right, so this was a review of the dynamic memory allocation and resizing. And that brings us to data formatting. So what I'm going to do with data formatting, I'm just going to show you how the data is being formatted and how do we do foolproof reading and all the good stuff. And 1140, we are actually, what OP? Is it is it 1140 really? Holy schmoly. Okay, we cannot do the other part. The other class started. I have to go to my OOP345 class now. Okay, is it 1140? 345? Holy schmoly. Okay, so thank you very much, everybody. We just did a review of everything, and the next day you are coming in. We are, which is going to be. Oh, wait, I looked at the wrong place. Why nobody's objecting to what I'm saying? I was looking at Tuesday.
Professor, our class ends at 12.
I know, I was looking at Tuesday by mistake. That's 11:40. It's 12:35. So we are perfectly good actually. It's a perfect time for a break. I need to go kind of do something to my back. Um, so we'll be back in 10 minutes. My apologies. I was looking at the wrong thing. So I'll pause the recording. Please, when you come back, remind me to resume. We have some important stuff to go through about foolproof data entry and output formatting. See you in 5-10 minutes. All right. So I'm going to call that one into main. Uh, what I want to ask you to um, please review this int array closely, because at the end of the semester, when we get to templates, I am going to use this for you to show you what a template is, and this is a perfect opportunity to jump ahead in your OOP345 by a week if we do this. So when you are coming to OOP345, you will be much more comfortable with templates over there. So review this, go through it, modify it, add bells and whistles to it. Anything that you think is uh, needed, make this array something that you want to use. Let's put it that way. Okay, all right. Put this one out of the way and let's continue. So we want to talk about formatting the output and foolproofing the uh, text input. Okay, that's what we want to do. Let me put, where do I put it? Okay, so I have prepared an MD file for this, and I'm gonna post this thing with the stuff. So this is essentially the MD file that I set it up, and I'm going to modify it as I go through with my examples that I have. So you're going to see exactly what it is, and this big name is going to be there. You can open it up and actually see on GitHub and see the things. So we want to learn formatting using OOStream, do foolproof text input handling using iostream, and use a function called peek to foresee what is coming next in the input for foolproofing. So in C++, when you are getting an input, you've been bound to receive the input first and then validate it. With peek, you are taking a peek to see what is the next character that is coming in without actually reading it, so you can give them some reply. This is very useful, especially when you want to receive something and and the user only enters enter. So you're saying enter an integer, user just hits enter without entering anything. With this, you can check if they just hit enter, then you can, you'll see. G count tells you how many characters been read. It's useful if you want to, for example, hit a phone number and you want to make sure that the phone number is exactly 9 digits. So with this, you can check if it's not proper, then we'll do. We're going to understand how get function works, which is essentially doing three different things. Get function can return a character that is entered from keyboard, or it can return the characters as received by report through a reference and return the IO stream for cascading, or you can receive a lineup of characters. So three different versions for get. And get line over here is a, uh, an alternative to the get function for receiving um, a string. Let me shut this up. All right. So let's start. I'm just going to take the code that I have over here and bring it over in here one by one, so we'll see exactly how things are happening. So we're going to have something like integer val, and I'm going to set it to 123, and uh, what I can, oh, using namespace. Okay, if I just print the val, it's going to print one. So to see what I'm actually dealing with over here, I'm gonna do it like this. I'm gonna put an asterisk like that, and I put an asterisk after. So when you print val, this is what happens. Essentially, it puts that 1, 2, 3 to the available space that I had. If you want val to get printed in a specific number of spaces, you have to get into, because this one returns C out, right? So you have to let that be and break it and bring, so the next statement that is printing this is this one. Then you can say C out, the width of the next output, I want it to be 10 spaces. So what happens is that this is going to get printed. It's going to set the width for the next output for 10. Now val is going to get printed in 10, and then it's going to go out. So let me actually put the other one too, so you see the difference between the two. This is what we had before, and this is what we have after. So now when you run it, you will see that the second one actually gets printed in 10 spaces. Now, you can always fill the spaces that, and again, one more time, if you print something after, the width remains what it is. Width is only for the next printout. But then what you can do over here is this. You can actually have that width set, but you can say, I want the rest of the empty spaces over there to be filled, say, with dots. And that's a single character you put, which means you not only are putting val in 10 characters, but you're actually putting the filling it with spaces if needed. Are we okay down to this point? All right. So the same thing that can happen, the same thing. So now we can actually print double values too for this. So if I say over here int dbl, and I put over there 1 2 3.456789 and 1 2 3 4 5 6. If I do something like this, um, I can do the exact same thing to print this out using val and the width, and print it out. So is it still val? Didn't I print double? Where's my double? Oh, I put int. Sorry, double. Okay, there you go. So I print my double, and as you see, it puts 3 digits over there after the decimal point. And you will see later on that it tries to find the best way to print it. So if the next time I'm going to just say C out double and just print it by itself, same thing. If that's not desirable, you want to change that, you can set the precision to something. So if I say over here C out dot precision, say I want 5 digits after the decimal point, and you ask the compiler to set the precision, this is what's going to happen. You see, it doesn't make sense because the precision you're putting over here is putting it for the entire thing. If you want the precision to be a fixed value, you need to say, you need to actually set the flag for output to iOS fixed. Now doing so, you will see that will be the difference. You see that? So when you are setting the precision, you have to set it to fixed. If it's not fixed, then you are essentially, whatever you are telling to the compiler tries to find the best thing that it finds fit based on its own decision to print it out. You don't want that. So whenever you are setting the precision of the value that you are printing, make sure that precision is, and fix is once, you don't need to do it many times, which means if I print it again with a lower precision, let's say 2, you will see that it actually takes effect and makes it 2. And as you see, it rounds it. You see that? This is 5, that's 6. If I come down over here is 5, it's going to be 5 still. But yeah, so rounding happens. But if I come over here for 3, if I say 0 precision, it's not going to be, this is not going to become 4 because it's 4, it's less than 5. So it always sees what is the next and rounds it upper and lower depending on if it's higher than 5 or lower than the other value. Are we okay with this? Let me see, how can I? Oh yeah, that's better. Uh, Let me just do it like this. Are we okay with this? Yeah, so just gonna do it like this. There's no answer where they just mentioned what it is. Perfect. Okay, goody goody. So these are the ones that we've done. Another thing that you need to know about, let me just, width and precision. What you need to do over here is setting and unsetting. So I'm going to come back with this double thingy that I had over here with the precision of 2. So I'm going to put over here like this. And I'm going to use the width. So I'm going to say cout dot width. So I need to have over here cout. I'll put parentheses instead this time, or square bracket is better. Square bracket, and in here I'm going to put a square bracket after. So in here I'm going to say width, I'm going to set it to 20. So the width is 20. Okay. Now I'm going to say, so if I just print it as is, what you will see, oops, I compiled the wrong one. Copy. Okay, good. So that's that. Save that. I changed the wrong file. Okay, so if I do it like this, you know it's going to get printed like that and it's going to go at right. You see that? So if I want it to be at left, I can actually set the alignment over here. So what I can do, I can say cout dot set f, and I can say iOS left. Okay, and I just print it like that. Okay, as you see, it's at left side now, so I'm going to just print it again. Now I want it to go back to right, so I'm going to go right justified. It went right. Now I want to go back again and make it left justified. You see that it didn't happen. So a very good practice is to, when you set a flag, unset it afterwards immediately, so it only affects what you have there. So we are supposed to do left justified all the time. If you don't want to, you want to change it to another direction, for that double thing you are doing that, immediately copy after and unset it, which means I did my printing over there and I'm done. And for the other ones, I'm going to unset it. Doing that is not going to cause the problem that you just noticed. I'll later on explain when we get at the end of the semester and we talked about bitwise operators, and you'll see that that's the reason that this is happening, the way it's actually working. So now if I actually set it up like this, you will see that left and right is set properly and everything is fine and dandy. Are we okay with this? And I know it feels like lots of pain, and I see you put a dash and it becomes less justified, dude. And things like that. You do things like that over there, it seems easy, but when you put some time and make an object format itself properly like this, you are done. You don't need to think about it's getting printed later on. You tell it to print itself, and when it prints itself, it's going to print it in a proper way. There is an easier way of doing this, and those are called manipulators. Go read them. We have it in the notes. It's not mandatory to know. This is better. You know this. If you know this is better, that you can learn it on your own. If you use it, I have no objection over it. You can use it, but this is what I teach. Manipulators are essentially doing something like this. Just give you an example. So this one is left and right.cpp. Okay. So with manipulators, this is what happens. So I'll go include IO manip, and then I can say cout set width, if I recall correctly, to 20, fixed, precision, set precision to 2, and fill with dots. Set fill, I think you should say set fill, if I recall correctly, to dot, and now print DBL. Okay, and when you do that, and this happens. Now you could have actually said over here, I want it to be printed at left too. And this is what's going to happen. Okay, so manipulators are things that you put right in the command, and because they sit in a way of things getting printed, they are called manipulate. They manipulate what is passing through it. I don't like it. I rather use iostream, but if you want to use this, learn it on yourself, but don't ask me to debug it for you. That's not what I'm going to do. You have to find out how to work with it yourself. Are we okay down to this point? So in here, I'm going to say CIO manip, learn yourself. Okay, that's that. Okay, now we are going to talk about iStream and OStream. iStream and OStream are extremely shy objects, which means if you don't talk to them properly, they're not going to talk to you back. Okay, if you, I'll demonstrate. So in here, I'm going to say um, integer val, and I'm going to say cout, enter a number, enter a number, and then I'm going to say cin val, so I'm reading a value. Now I'm going to say cout, thanks, another number please, cin val2. I'm going to say vval is val, and val2 is val2. Now, the purpose of what I have written over here is to show you what happens. So if I actually mention over here 1, 2, 3, and I hit enter, and I put 2, 3, 4, the values are entered properly because I put the things, uh, uh, entered the values properly. Not only that, you can do this. So if I say Control F5, I can say over here 1, 2, 3, and I put spaces, and then over here I put spaces, and I put 2, 3, 5, 3, 4, 5, and I do it like that. It will still read it. Why? Because the extraction operator skips leading spaces. Extraction operator skips leading white space. Sorry about that. When you have back pain, one of the worst things you can do is to sneeze. Anyways, so extraction operator skips leading white space characters. What does that mean? It means it not only, so I can go 1, 2, 3, 4, and I can, so it reads that one, then I can go space, then I can go tab, and I go enter, 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 then I'll go 3, 4, 5. It reads it. It skips all the white space characters until it hits something, and then after that, it stops. Do we understand it? All right, good. All right, so that's that. Now, what I want to tell you is this. If you give it garbage, if I say ABC and I hit enter, it completely ignores everything and goes through. Let's see. So when I put 1, 2, 3, let's walk through and see what happens over here. In here, I'm reading a character. Instead of 1, 2, 3, I'm putting ABC. ABC is not a number. Because it's not a number and I hit enter, Cin fails to read because it was expecting a number and we gave it garbage. So it can't read. When it can't read, it goes into a fail state. When it goes to a fail state, essentially it becomes disabled. Even if I come to the next one, even when I'm coming to the next one, it wants to start reading, but because it's in a fail state, completely ignores what you're saying and bypasses it. Therefore, the first one's gonna have, I don't know, in this case, zero value in it, and the rest is gonna be the garbage because it's not even executing any values. So, do we understand the fail state in iostream? All right, so we can always use this feature to track and see if the user is making a mistake by doing by, how can I do that? I can say something like this. Instead of just reading a value over here, I can say while cin.fail. It means if I am in a fail state, okay, sorry, do read, okay, and then after you read the value, you have to check. You have to say if cin.fail. Oh no, let's do something else. I want to write something in the code I want to write over here. I want it to be. I don't want it to be perfect. I just wanted to teach what it's supposed to be done. So after I do cin, okay, if while cin.fail, let's put it like this. Now I can say if user entered something incorrectly, first of all, I have to apologize to cin. Say, hey, sorry, garbage came in. So I have to say cin.sorry. No, you don't say sorry, it's just actually say clear. Okay, so you say clear. That clears the status of cin. Cin goes back to normal. Now that the cin went back to normal, remember I have lots of garbage in here. If I try to read again, same thing is in there. It couldn't read it. Now I have to clear it. To clear it, there is a method called ignore. I can say cin dot ignore, and ignore has two different ways. Either you can just blindly ignore everything, say I want to ignore 10 characters. It means the user is entering something, I want to ignore the next two characters and read the next one. You can. Or you can say ignore up to a character. Now, all the data entry ends with new line. So what I can do, I can say put some ridiculous number, ignore 10,000 characters, 100,000 characters, or backslash n, whichever comes in first. Okay, now if I do something like this, it clears, it keeps reading until it hits backslash n, and the backslash n is removed too. Now I can actually say cout invalid integer. Try again. And now I do another cin val. So in here I can now say cout, you entered val, and the val that is coming in is definitely yours. No uh, doubt that it's going to be done perfectly. So if I do this, it says invalid. If I do this, 1, 2, 3, it says invalid. But as soon as I put 1, 2, 3, it doesn't fail and it comes out and validation happens as follows. Are we okay with this? All right. So next one. So this one is validation cd validation using fail, clear, and ignore. Okay. Next thing is get line. Okay, get line. What it does, um, it is to receive a series of characters up to a delimiter, whatever you want. So in here I can do something like this. I can say um, I'm going to say character name 41, character surname 51. Okay, now I'm going to say cout enter comma separated name and surname. So if I want to do this, what I can do, I can say cin.getLine, and I can say for the first one, it's going to go in name, and for the size you put 41. Remember, getLine wants the real size of the array. It will take care of the null, don't worry about it. But it will need the exact size of the array. It's not like before that you do 40 of it and then you add and all that in. It will do it automatically, but it needs to know. Now I have to say stop at comma. So essentially it reads and extracts the comma 2 out of the thing. And now I can say cin.getLine surname 51. I don't need to put anything. When you just put getLine, the default delimiter is \n. Okay, hello name surname. So what happens over here is this. When I write over here something like I can write over here Fred, comma Soleil, and I hit enter. So Fred will go up to comma red, and Soleil will go after that. But remember, get line is not extraction operator. It's get line. It reads everything up to the delimiter. So if I write something like this, and hit enter, it reads everything. It doesn't care. It needs the delimiter, specific delimiter, to be read. Do we understand this? Good. And another thing we need to understand about getLine is this. I'm saying over here Fred Soleil, so that's Fred needs FRED. That's 4 characters. I'll put over here 6. SOLEY. That's 5. I'm gonna put over here 7. So now in here I'm gonna put 6, exact same size for that, and 7, exact same size for this. Now I'm going to run it again one more time. So now instead of Fred Soleil, I'm going to say Fardad, comma Soleimanlu. And I hit enter, and you will see that it actually fails in reading. So get line, if it reaches to the limit, get line, if it reaches to the limit without reaching to the delimiter, will be failed. Of course, it's going to copy whatever you had in there down to the point that you read, but it will fail. Okay? Keep that in mind. Are we okay with this? Okay, get line will fail. Okay, so let me make sure it runs. Okay. Perfect. Save that. Okay. What's the time? 29. The class ends at 12:30. Yeah, I'm gonna stop it right here. I'm gonna post the things that I put over there, the kind of outline of things. Read that the next day you're coming in. I'm gonna complete this and write you a foolproof data entry command to clear things up. That's gonna take around 15 minutes, and then after that we're gonna hit the inheritance. Okay, questions? Any questions? All right, so the MD file will be up there. Let me just save it. File, save. Okay, and that's that. Okay, have yourself a beautiful day, and I will see you on Tuesday. Bye, everyone.
Sorry for that. So I do have a question for you.
Okay.
Uh, let me just. So the recording for this lecture, will it be up like what? More or less, when will it be up? Is
In
it gonna be up available like?
in 10 minutes on Big Blue Button on
Oh,
YouTube.
okay. So it's
Are
just
you?
uploaded automatically
Yeah,
into
yeah. It's
Big Blue
on Big
Button.
Blue Button. You go as if you want to join a session. You can go to the recording. Okay.
Oh,
But
okay.
on
Okay.
on YouTube, I have to organize everything, so I really don't
Okay. Okay. Sounds good.
know. Okay.
Thank you.
Have a good one.
Have a good one.
Bye
Have a
bye.
good weekend.
Bye bye.
Bye bye.